in various places. Are we live in the restream? We are live in the restream. Okay, that's a good start. Are we live on Twitch? It appears so. Are we live on... So this is muted. Testing. I don't hear anything. Am I not getting audio through? What about this? So, are we live? Okay, we have audio on YouTube. Twitch hasn't updated yet. Are we live on Twitch? We are live on Twitch. Do we have audio? Are we live on Twitch? Yep, we do have audio live, and we're live in all three. Okay, welcome to Code Hangouts number 221, where we're once again looking at the counter anti-cheat, counter API anti-cheat. I don't see this transmitted to the Twitch chat or the YouTube chat. Are the chats not connecting? Oh, that's not great. Can we try this again? Well, one second, let me see if the chats go through. Let me reopen the restream in another window, see if that works. It's showing me a circle. I don't know what the circle means. The chats haven't gone through though. Let's try again. Try reading the page. I literally just loaded it. What are the errors that we're seeing here? Failure to load the resource. Uh-oh. Seems like the restream chat isn't working. You know what? I'm just gonna put it into the chat myself. No, not that. No, no, no. Just a welcome message, please. It somehow cannot connect to the chat. I don't know why. It doesn't seem to work. Hey, Marek, thanks for sending the test message. So yeah, it's not showing up. Oops, something went wrong. Try reloading the page. I'm reloading it, and every time I'm reloading it, I'm getting an error. Service unavailable. What the heck? There is a chat embed possibility. One second, let me see if I can get the chat, because it popped open a chat window in OBS. I have no clue how to get back to that. Chat. If I do this. Hold on, we're connected to your channels. Okay, so it's still struggling. Please enable channels here. Uh-oh. What are you talking about? They are right there. What do you mean enable channels? I'm connected to two. Hold on, we're connecting your channel. Oh my god. Well. Issues with restream chat from the Restream Help Center. Well, I guess instead of doing what I wanted to do, we're trying to debug this. Restream email structure for platforms reports reading comments. Yes, it does. I'm live. It's the same I'm doing every week. Can't open chat application on my Mac. Well, that actually doesn't really work. Okay, now it says something. Is this gonna go through? Okay, well, it went through on Twitch, but it didn't go through on YouTube. Connection in error state. Why? One second. Restream. YouTube chat. Connection in error state. What a useless error message. What is the error? Removing reading the channel. Yeah, I'm not gonna do that in the middle of a stream. Okay, I'm gonna have to then keep an eye on the YouTube chat myself, and maybe I'll put the Twitch chat up here, or actually I can maybe put the restream chat up here if the Twitch. It seems to work for Twitch. Maybe. Maybe. YouTube, no bueno. No, now it's once again not working for either one. Maybe it'll work here. Yeah, I think this one, it's this. Okay, this one window is completely behind. This is very annoying. All right, I'm gonna leave it on the YouTube channel chat for now, and I'll check the Twitch chat from time to time, and maybe eventually the restream chat will work again. I don't know. But right now, it's just spinning forever, and it's not doing anything. Like basically, this is what I'm looking at the moment, and I don't know what the hell's going on. Status 500, back in chat, restream users 1, I don't know. Why is it giving me these errors here, or it's just stuck forever? Pending pricing details, I don't know. I'm not a paid user, so maybe how they handle the free tier has changed. Like, what the heck, internal server error? What is the error? Error, internal, okay, that's not useful. Well, not much I can do about that right now. Huh. Pair channels, embed webplay, embed chat. If I just have embedded, because I have this chat only view as well, maybe that'll work where the regular chat window does work. Okay, nothing is happening here. All right, I'm just gonna open it on the YouTube chat and hope I'll keep an eye on it. Okay, so where did we leave off? Last time I left off by trying to build a way of configuring the different penalty levels, if I quite recall. So let's see how that's set up. It's been a long week somehow, and my brain is kind of flushed of anything we did last time. So the penalties are configured here. So the way I'm interpreting it right now is that basically what happens is I was trying to set it up in such a way that every time we need to think about a penalty, it goes through a particular function, right? So originally what happens, because here we're basically running a simulation, right? We're feeding in log data. So this is basically what would normally happen once per request, right? And here we're just simulating a bunch of requests by feeding in log data. And the only information we have is the IP address, the counter ID, and the row date, right? What checkkit does currently is it first checks if this user or this IP address and ID combo is already being looked at. If so, we'll update whatever penalty runs, right? If not, we're looking through our queue, right? And if we find this entry, this IP ID combo in our current circular queue already, we'll create a guard and we update the guard. And create guard, I believe, just creates it creates this. Yeah, so it basically just creates a level 0 count 0 date and time entry on that IP address and ID, right? And then update guard deals with making that change. And update guard gets fired here, or not at all, right? Otherwise, we're just adding the item to the queue, and we're also, first we're removing, making sure our queue isn't longer than our maximum queue length, and then we're just pushing these 3 data items onto the queue, right? And the reason we're doing it this way is that even on the second time we're encountering ID-IP combo, we already have all the information available, right? So we basically only care about update guard, right? And here we're basically saying, okay, we're doing a sanity check. If this IP ID combo exists, right? And we probably wouldn't even need to do it this way. We could just check first for the IP and then for the ID, whatever, right? Then we're running a cooldown guard function. So we're saying, okay, if this guard exists, we want to make sure that we have a cooldown running, right? That means if you're hitting, you know, we have some sort of method of saying, okay, if hits happen a certain period of time apart, you actually get moved down from the penalty levels, right? So for example, if you're spamming it, you go up, 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 up. And then if you don't touch it for a day or two, you know, you get removed again. And this is basically said that we're not tracking, you know, IP addresses from a year ago, right? And currently, I think we're looking, so to cool down a guard, and this, because we're kind of doing it every time the guard exists. Okay, so the idea is that we're exiting as quickly as possible, and then we're hitting the queue, and then we're unqueuing, right? So ideally, this is as fast as possible, right? Because 99.99% of all hits shouldn't be second hits. So the case when we're not dealing with an attack needs to be as fast as possible, because ideally that'll be our vast majority of hits. Now, dealing with an attack needs to also be efficient, because obviously an attack will have lots of hits, but that's why we're doing that first, right? So once we're looking at the guards, there aren't as many guards as there are queue items, hopefully. In my tests, for example, of here we have 827,000 hits from our logs, and it created only 809 guarded items by the end, right? So much smaller number, right? And that's with a queue length of 1,000. We might even want to reduce that. So that's something why I want to test against the logs, so I can see, okay, how does it, what would have happened if the system was live in the last year, right? And then we can run through and see, okay, how much performance does it cost us? How much, you know, for example, it took 4.3 seconds. So 100,000, currently the traffic is around 40,000 a day. So that would be 80,000, that would be 20 days worth of traffic. So 20 days worth of traffic would have taken 4.3 seconds of CPU time on my machine, right? So it's not a lot of time at the moment, right? One of the issues I have is that currently the queue isn't indexed. So it linearly searches through this queue, right? So we have to loop through 1,000 items. I have considered indexing it, but I think it doesn't make sense while the queue is very small. So the queue currently is 1,000 items. Looping through 1,000 items doesn't take very long. And maybe maintaining an index might actually cause more issues. Right, there's definitely some mechanical issues with this connector. Okay, so the penalties currently are designed as follows. The first penalty level, so the first time we're checking anything is on the second hit, right? So on the second hit, we're saying, we're checking if not cooldown guard. So if cooldown is so the cooldown is basically saying, okay, how do we cool down? Good question. So we're calculating the delta time bit, which is basically the last marked time on our entry, which is, you know, basically the previous hit. And then each penalty level has a different cooldown. So the first cooldown, and I think these are in seconds, right? So that would be 10 minutes. So basically within 10 minutes, it will ignore a second hit. Or at least it won't, it will remember the second hit for 10 minutes. Let's put it that way, right? Because if it's smaller or equal to penalty cooldown. So the cooldown hasn't expired yet. We haven't reached the cooldown yet. If we've reached the cooldown, we're checking the guard level. If the current guard level is 0, is 0, right? So let me. A guard has DT level and count, right? So let's do something like this. Right, and then here we have guard is DT level count, for example, right? If we're at level 0, we're just removing the guard completely. Okay. Otherwise, we're going down by a level. We're setting the count. Okay, so we're not removing one entry. So if we had 1,000 hits and you reach the cooldown, all those 1,000 hits basically get, if you're on a particular level, you get removed down by a level, right? We might have to change that. I don't know. You're going down by a level. Otherwise, you go down by a level. The count is reset to 1, and we're updating the date time. Okay. So that's taken care of. If we're not, and if we've done a cooldown, we're not incrementing the count because the cooldown already took care of this. Otherwise, we're incrementing the count and we're updating the date and time. Now we're figuring out the penalty, if there's any change to the penalty, right? So basically, we're checking if the penalty has a maximum count and if the count is greater or equal to the maximum count. So in this case, max count is 2, right? The second hit will bring the count up to 2. So this will be true, and this will be true. The level goes up, the count gets reset. Will be at count 0. Does that make sense? No. I think count needs to be set to 1. Here. Because that's our guard increment, right? Unless we move the guard count to down here. Now, if I'm just realizing, if the cooldown removes the guard, we actually don't want to do that. Right? If the cooldown guard is true, yeah, if we're cooled down, we don't want to increment the penalty at that point. Right. So if cooldown guard is true, which means a cooldown has occurred, we're actually returning from here. We're not going to increment the penalty right after we've just cooled down. That doesn't make any sense. That would only make sense if we have a penalty at 1, at max count 1, which never should be the case, right? So now we basically back to here, and now this can just go down here, and then this being 0 makes sense, because now we're always incrementing the count unless we've had a cooldown. Right. And I'm wondering if in this case, if we haven't reached the cooldown, if our is smaller equals to, no, wait a second. No. I'm screwing something up here. Only if the guard is removed is when we want to skip out. So we have 3 cases. The guard is removed completely. We've cooled down and we've gone down by a level, in which case we don't want to do any of the other stuff either. So wait a second. If we're returning false, that's when we want to do this stuff. Otherwise, we don't want to do this stuff. So if cooled... Okay. My brain. All right, so in this case, we're returning false and we're continuing. So if cooldown guard, okay, no, this is still correct. Turn. So if cooldown guard, we're not. If we're cooling down, we can never go up by level. Okay, level cool down, no increase. So then we go here. We're doing that, and the count increment goes here. Okay. Okay. Penalty max count. Do we need penalty for anything else here? Because I'm just thinking we have looked at the penalty here already. I'm tempted to pull this into one function here. The only reason I put it here is because I was using the cooldown guard, like I was doing a batch cooldown. So instead of doing a cooldown on each hit, I was thinking, okay, we could do a cooldown every 10 minutes or whatever, right? But we'll probably, because the idea is that something could sit in there. If it doesn't get hit, then it would never get removed, right? So occasionally we do want to cool things down, basically. So that's why I have, otherwise I would prefer to have this code in here, because then we can, these dereferences and stuff, we don't need to calculate the same thing multiple places. We also only need max count here, so maybe we'll just do that. Right. Guard.level. Does guard.level change? Yes, but not, if we're exiting, then it doesn't change. Guard. Penalty. Penalty here, we're only looking at cooldown. So we can just do that. Right? And guard, we use a bunch of stuff. Okay. All right, so back to our example. If we're not cooling down, our count goes up. At that point, we'll reach count 2 because it is our second count. So create guard will set us to count 1, I believe. Ah, wait a second. Okay. No, yeah. Create guard needs to set us to count 1. Because we're creating guard. Yes, we're creating the guard on the second hit, but we're also updating it at that point, in which case it will get incremented to 2, right? And we're basically pushing it in as if the first hit, because we don't want to create a guard on every hit, right? Then our guard list will just be our queue, basically. So actually, count needs to be 1 here. Level is still 0. So then, here we're creating it for the previous. So this is actually... Yeah, for DT0. Okay, so because these are the same, it doesn't matter which one we're referencing. Fair. Okay. Initial queue, create initial guard, and update. Okay. So that gets us our first hit. And then update guard. This should be always count 1 after the increment. And after the cooldown, it should also be count 1. It should be count 0. Count 1, and we update the DT. Yeah, because we're not executing this. This always happens, but we need to have the original one. Okay, fair enough. So that means the first 2 hits, the second hit doesn't count. After the second hit, if we haven't cooled down, we'll go to penalty level 1. Penalty level 1 does allow 30 hits through. So the second hit gets constant. The next 30 go through for cooldown 300. And the reason I did this was because I wanted to be able to let classrooms submit and things like that. The problem with it is that I kind of want this to cool down quickly. Like, I don't want... Yeah, so I'm now thinking about this because that means our spammer will get 30 hits through, and then they just have to wait cooldown, and then it can do 30 hits quickly. So what I really want is, I want the second level to be on a fast cooldown, so we keep getting knocked down to the first level. and then the second hit. Actually, the second when we get knocked down by level, we should get knocked down to the max count, I think. Yeah, I'm starting to think that cooldown really does need to decrease the counts. Because what I'm thinking now is we get the second hit, we're skipping it. The third hit we want to count unless it's within a short period of time. So we basically want to go to the level 2 and then have a relatively short cooldown that knocks us back down to level 1 to make the third or the fourth hit count. But we want to go up to the next level very quickly. So if the third and fourth hit are fast, we want to go up. The problem is we don't want to go up and down, because then we can't say how long we're going to stay there, right? Yeah, it's almost as if the cooldown and the count isn't enough. It's almost like we need a rate limit, right? We need to say if our average hits per period of time exceed n, you know. So let's say we want to accept 30 hits over 5 minutes. If we're exceeding that rate, we're going up. And I'm starting to think, again, like, I've been thinking that the design goals I've set myself for this are unrealistic. That I want to cancel technical errors of double submissions. I want to allow multi-submissions on singular IP addresses in terms of classroom use. And then I want to block mass use. I think I need to drop the second requirement and either hope that classroom situations will have multiple IP addresses, or they're so rare that, you know, losing those counts isn't a big problem, or just deal with it and update it, the system at the time, right? Maybe have a bypass for classrooms that I can control somehow. So I'm starting to think I literally just want to have a simpler system where I don't go through these penalty levels, right? And we'll just have a, you know, we'll have just the guard, and we're not going up and down in levels and counts and all this stuff. And we'll just have a timeout, right? So if the DT is large, if the DT is greater than a certain amount of timeout, they just get removed. And then in the future, maybe we'll do a more complex system, right? So I think we'll get rid of the cooldown thing. We'll get rid of the penalties, right? So we're creating the guard. And now we don't... The other thing I was thinking also is that we might want to log additional information, right? So, and I don't want to spam my logs up too badly, but we basically want to have some separate log where we say, hey, every time we're putting somebody on a penalty list, we'll log these entries so we know, oh, you know, we can look at in after the fact, right? That, oh, this IP address is doing funny business, you know, and he's done it 1,000 times or 100 times, or, you know, he's gone up to 5 every hour or every day, you know, so we can see these kind of attacks, you know, because not everybody's going to do 40,000 in an hour. Somebody might say, okay, I'm just going to add 100 every 6 hours, right? And I'd like to see that as well. So what I'm thinking right now is, I think I'm going to simplify this down. I'm going to remove all the penalty stuff and the guard stuff. So we go back to create guard, right? Do we want to do any of these things, or do we just count, like just keep track? Because what I was thinking also is that we could have a cooldown, but if we have a count, then we could say, okay, the larger the count is, the longer the cooldown gets, right? So our cooldown is an average hit rate. So if the hit, you know, so if somebody hits it a lot, their cooldown goes up basically a lot, right? I mean, what we could simply do is we could just increment the count, and every X period of time we're reducing a count, or or every time we get a hit, we'll reduce the count by the period of time since the last hit divided by a number. Let's say the count goes down every 5 seconds or every 10 seconds or something, right? And once again, am I making it more complicated than necessary? Because what we could just say is, okay, if they wait for half an hour, it gets reset, and then they can do another hit, right? I think that makes the most sense, really. So we don't need a count, right? We'll just put them in. All we need is the date and time then. So create guard just becomes DT, doesn't become an object, right? We don't do the cooldown right now. We don't do that. We don't do any of that. All right, so if the guard doesn't exist, update guard doesn't do nothing. Create guard now simply stores the date time and increments the guard count. Okay. Now we're hitting update guard. And I'm trying to think, is there a way of making this simpler? Because the guards are not that complex now. Like, am I better off just putting that into the guard data? I mean, the reason I have an array of arrays basically is just because it's easier to manage as a queue, right? Otherwise, I'd have, because our guards here is a tree object basically, right? A list of IPs, and each IP has a list of IDs. If the guard is undefined, we'll skip out. We return false. So this returns false, and then we go here. Okay. If it's true, we gotta calculate our delta t. So we kind of do this, right? We have guard already, so we'll say const delta t equals dt minus guard dot d. Yeah, guard is now just a dt value, right? And then here we have max queue length, and then we have guard timeout. And that'll be, so let's say for testing, let's say 10 seconds, right? So if our delta t here is in seconds, right? If delta t is greater or equals to guard timeout. So if we've timed out from the previous hit, we want to treat this as the first hit. So we're just going to update the DT, but not, well, we're just going to update the DT, right? Actually, no. One second, because we have a hit. Wait a second. If update guard IP ID DT, the first update guard, here's actually where we're gonna check that. So what we're really gonna do, we're gonna do this, right? And then we're gonna see, okay, so if guard exists, right? If guard exists, we're gonna calculate the delta t. We're gonna check the timeout. So if guard exists, we have our delta t, right? If the guard exists and we've timed out, we're going to treat this as our first hit. Again, so we're not going to put it into, we're not going to put them back into the queue. No, we got to put them back into the queue, because if we're going to treat them as our first hit, if we're going to, one second. If we're timed out, we're going to treat it as if they don't have a guard. We're going to treat them like a fresh request without a guard, which means at this point we kind of want to delete the guard, but we might bring the guard right back if we find it in the queue afterwards. So I don't know if memory-wise we're better off doing this check leaving the guard in place or removing the guard. Because right now, remove guard does this. Now, if IP ends up empty, what does that look like actually? If we have a property, 1 second. If I do this, will this even run? No, because I have a syntax error here. Right. So, unexpected token. The same issue here. 320. Right. So if I have an object, let obj equals 0 object 1 0 a 1 b yada yada. Oops, and we'll do this, right? And then we'll output it. Oh, like that. So we get that, right? We can probably output this also. I wish we could get the color, the colored version out of JSON stringify. I guess I'd have to write that myself, the code for that. Yeah. So if we're now deleting a specific item like this, 1 0, it'll look like this. But if we're deleting both of these, the 1 would still be there as an empty object. All right. JavaScript check if object has no keys efficiently. I don't want to run object.keys. Any properties? I mean, it doesn't happen that often. So carry out above the workaround is more abused. What? So I guess we can say if object.keys obj1 dot length equals 0, then we'll delete that level object as well. Right? And then that'll get rid of it completely. Okay, that's fine. Those kind of removals shouldn't happen too frequently. So then we can just say, okay, if object.keys.length 0, we'll do that. All right. Well, I tested it. Now no. Also, I want to be running test runs without going through the full set. So if I do it on 10,000 rows, it should be a lot faster. Yeah. So now we're back to a simpler version. That's not fully implemented right now. So let's... Oh, what did I just do? I didn't want to drag it out. I want to make it smaller. There we go. So we now want to run. We're running check hit. If guard is undefined, we do something. Let's do it in the right order, right? Okay, so if we have a guard timeout, we'll just remove it. We'll just say remove guard and let it sort out the details. like that. Boom. So now the guard doesn't exist anymore. Now we're checking the queue. If we find it in the queue, we put it right back into the guard. Now, is that a problem? Because what's in the queue, like if we were removing something from the guard, I almost feel like it needs to go in the queue, except the queue, yeah, because if they're still in the queue, because I don't actually know if, yeah, we kind of, the problem is I'm kind of operating backwards from how it works in real, like what we're actually doing is we're doing this first, if something isn't in the queue, yada yada. But we'll do the checks in the reverse order because they're faster, right? So there's few guards, so we can check the guards very quickly if there's a guard or not, because there's very few of them, right? And if there's a guard, we want to deal with them right away and not mess around with the queue. Because I'm also thinking now, before we add something, we actually want to check if we actually have a timeout situation, right? So we don't want to blindly add something to the queue when we're add something to the guard if we're finding it in the queue, right? So if we have a match in the queue for this current IP, i.e. there's a potential reason to add to the guard, right? So then we want to do this. And we'll probably want to do a let delta t at the top. And I'm wondering if there's a case to be made, like having a little helper function that just says, is dt timed out, right? So we can do a function, is timed out, dt0, dt1, right? And it'll just say, basically, this, and we're assuming dt1 is the larger number, right? And then is greater or equals. So it's just going to be return this greater or equals to guard timeout. Is guard timed out. And that feels wrong. Is guard timeout, right? So now we can just say if is guard timeout dt guard. And I'm wondering if now we'll do this, right? If guard timeout guard dt, we'll do this. Here we can say if not timeout. If it's a timeout, here we're just gonna skip it. We're not gonna add it to it. If is not guard timeout. Now I'm thinking this could never be the case, because if something is in the guard list, we're not adding it to the queue. So there could not be anything in the queue that's more recent than the latest guard. So if we have a timeout here, we don't need to consider if it needs to get added back in because it's timed out, right? And that's relative to the last access. So anything, yeah. So at this point, we can literally just return. Or I'm going to change the order because we might have to, at some point, we're going to have to tell the code above if logging, if the request gets honored or not, right? Something needs to return true, false to, is this allowed? Is this API access allowed, right? This is actually a check function. So now we can assume this is never going to be a timeout. So then we'll check the queue, which is a slower process, and this is the slowest actually. This is, relatively speaking, faster. We'll probably could do this before here. Or should we do this afterwards? Yeah, we'll probably want to do this afterwards. Right. So now we do create guard. Create guard here is just going to be this. If the... Yep. If the guard already exists here, because I'm thinking now, if we're gonna just update the DT, when does that happen? Here somewhere. Okay, so for now, this is just gonna be create guard, and there's no update guard. So there's no updating. We're just creating the guard. Else, we're just adding the queue. We're updating the queue. Okay, now hit here, we're returning false, no hit. Here, we're returning true. Yes, this is a guarded thing. And then here, we're returning false again. Because we're just adding it to the queue and there's no problem yet. Right. Is this correct? Now, if it's not a guard timeout, if it's not a guard timeout, if the guard exists, do we ever do this? No, we never fall through, because if the guard isn't timed out, we're just immediately returning false as well. Ah, no, wait a second. No. If we were timed out, we're potentially adding it back into the queue. It needs to go to the queue. Right. Jesus. Okay, one second. We never check the queue. If there's a guard, we never check the queue. No. My brain. Can I don't want to duplicate this code. I can put it in the function and call the function twice, but I'm just thinking, is there some order of operations here that makes more sense? So step one is, do we have a valid guard? If we have a valid guard and it's timed out, we're gonna add it to the queue. We're gonna treat it as if it's a new hit. And we don't want to do this because we already know timing wise. So it means if the queue is really long, an entry could get added to the queue multiple times if the timing in the queue is outside of the timeout, right? So if the queue, for, if it's a quiet day, whatever, technical issue, the 1,000 items contain 2 hours worth of data and somebody gets timed out. Okay, so then we never want to run this, which is good because this is our most expensive operation, right? The question is, can we skip it? Do we ever? Yeah, so we never run this if we have a hit on the guard. We never run this. Right, so this is a full-on else on this. Else we do this. Right, and then we'll do this, right? Now, if we're creating a guard, we don't push things into the thing. But we're not creating a guard when we're coming out of here. Now, if the guard is timed out, we're removing it and we're returning false. If the guard isn't timed out, then if is guard timeout. Oh, no, yeah, okay. So if is guard timeout, we remove the guard, but we continue. If the guard isn't timed out, so if is guard timeout is false, right? We now update the guard. And unfortunately, having the guard, so we probably want to do guard DT. We want to rename this to guard DT. So guard DT, right. If guard DT isn't timed out, we gotta update this to the latest DT, and then return false. No, return true, and block it. Else, we remove the guard, and we continue and then queue it. We don't add it back into the guards. It's gone from the guards, but it exists in the queue in case, you know, after the timeout, it hits twice within the timeout, and then it'll get blocked again. The first one will go through, the second one will get blocked, right? Now, if we don't have a guard currently, we're treating the queue as if it's a temporary guard. So we check, is it in the queue? Do we worry about timeouts here? Yes. We don't want to add it if we have a timeout, right? If the item in the queue is already timed out, we can also ignore it, right? So if we have a match, and it's timed out, the question is, if we have a match and it's timed out, do we treat it as if we don't have a match and we just continue? I guess we do. Because then it's the same as if we had a guard and it was timed out, and we basically want to skip down to here. Except we don't want to skip because we want to continue through the queue. Except if the queue is in order of timing, the moment we have a match and it's timed out, we don't have to continue through the rest. Okay, so if we have a match and it's not a timed out match, we create a guard. If we have a match and it is a timed out match, we'll break out of the for loop. Okay, so at this point we'll have to do another one here, another guard, another timeout check. So at this point, if is guard timed out, and here we're gonna compare DT0 to DT, right? So if is guard timeout, then we'll do the create. No, wait. If it's timed out, we just break out of the for loop. We don't do the create guard, and we'll add it back into the queue. If it's not a timeout, we create the guard and return false. Right. I think that's how it should work. Okay. So let's add some logging here. We'll do create, no, update, right? Create. And then here we'll have remove. Right? So how many events do we have? Create, update, create, create, create. Okay. And we had no removes. Okay. So let's do IP ID DT. And we'll say update from what to what. Right? For remove, we'll just do this. And create, we'll also just, well, we can add the DT0 here. Wait, no, create guard shouldn't be with DT0. It should be with DT in this case now. And if we have a timeout, what does that mean in this case? It means we found it in the queue, but it's too far behind that we don't want to create a guard for it, which means we no longer look for the queue and we just add it to the queue and we don't create a guard. And the guard doesn't exist at this point. Okay, so let's see. So we're creating a guard for this and we're updating it here. Okay. Can I just do this instead? So we know, okay, so we've updated it by this, by 4 milliseconds or whatever here. So this is definitely with, you know, this is definitely a block, right? So this is blocked. And we're returning false, yada, yada, yada. Okay. And where does the check hit come in here? So here we'll just say let res equals, and then if res also that log locked. Something like that, right? So we have a block here. We have a block here. Now, how do we get 2 blocks? So the create happens on the second hit. The create is also a block. Let's indent it so we know when it happens. So the block, so create blocks, update blocks. So that's the 3rd hit on this guy. Create, create, create. So these are all just individual blocks. Okay. So let's crank it up to 50,000 rows. All right. So create, 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 block, 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 blocked. Guard counts up to 14. Okay. And let's do 100,000. Block, 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 blocked. Okay. And let's say blocks. Let's do a block count here. Now the problem is, once we hit that 40,000 spam thing, we probably don't want to output all of these. But I'm tempted to, you know, slowly increment until we hit it and then deal with it. Okay. So in this case, we have 81 guard counts. We have 118 blocks for 81 guarded IPs. And then how many timeouts did we have? I don't see. I can't see. All right, so for now, let's get rid of some of the log spam. And we'll just output the removes. Okay, so we had 2 removes. Let's say why they're being removed. What is the duration? Where this should be the larger number, right? So that should tell us how many seconds have passed for this timeout to kick in. So remove after 91 seconds, after 17 seconds. Our guard timeout is currently 10 seconds. Okay, so 17 seconds, you know, so in reality, this should happen fairly infrequently. Hey, Keith. No worries, no worries. You're always welcome. Today, I'm cutting down the complexity of the system radically because I need to get it deployed. Otherwise, it's just blocking other things I need to do, other things that are actually more important. So let's add some more test rows. Up to 300,000. All right, so we have 178 blocks on 133 guards. Now the question is, over a long period of time. Okay, so right now what's happening is we're not timing out existing guards. So we kind of want to eventually be able to like we'll want to have a timeout check, right? So function check guard timeouts. Right, and it's basically what I did here with the check cooldown. And we'll basically just loop through everything. And we'll just do it at the end, just to see, of those 133 guards, how many would stay after timeouts and all this. So IP in guards, ID in guards, IP. And then we'll have guard DT. Right? Oops. My muscle memory failed me. Here we go. So we have this. And we'll basically have to say if is timeout if is guard timeout remove guard. And we don't need all these braces. Right. So what we want to do then is, at the end, we'll want to find the latest DT. All right. We want to calculate the guard count here. All right, and then we'll do the full timeout here, and we'll output the guard counts again, which should be updated by then. And then here we should say new date, rows.length -1. So that should be the date of the last log row. So if we do this, we should get the same number, 133. If we get a segmentation fault because I have some memory issues. One of these days I'm just going to replace memory. Okay, so the guard count goes down to 1. Now the question is, how often should we time these out? And I'm starting to wonder if there's a, like, because it's an index, right? So we're directly checking them. Like, we're never looping through them. So if the number gets large, it's not really a big deal. But what we probably should do is we should have a max max guards number. I was going to say, if we exceed a certain number of guards, we should run the timeout, but that doesn't actually guarantee that our guards get reduced. And if we want to have a maximum limit to how many things we're guarding, which shouldn't be a problem. I was going to say it shouldn't be a problem, but I'm realizing that, because I was going to say, there's only so many IPs, right, that people have access to, even if they have a big botnet, you know. But the problem is they can potentially spam the counter IDs, right? And this check might happen before I check if the counter ID is valid. So they might try to overwhelm the database, right? So I definitely want to have a upper limit on how many guards we're adding. The question is, how do we handle exceeding that size? Because I want to stop accepting new guards, right? I want to ideally remove the oldest ones, right? And to do that, we need to have an order. We either need to have an order, or we have a relatively expensive procedure of basically sorting them by date, right? So now I'm wondering if the guards also need to be a linear list, similar to the queue. So we basically just keep adding guards to the end of it, and then popping guards, you know, and then just have a fixed length on that. Then the question is, instead of having an indexed axis like this, we'll have to loop through to find it. But we can still have a data structure that does both, right? We still... Is this... And I can't claim, you know, premature optimization here or anything, because I cannot have my server be vulnerable to a simple DDoS through a system I'm building, right? Now, it is already vulnerable, but I don't want to add to that, right? So it feels to me all of these systems should be a fixed length. So I'm almost looking back at something I thought about in the past, where instead of having a separate guard list, I actually keep them in the queue. So the max queue limit includes the guards. So everything on the queue is also the guarded items. And that'll be a way of removing them. So every time I'm popping an item off the queue, I'll check and remove those guards or time them out. Which means the queue needs to be longer than our guard timeout, which was not really the point. I wanted the guard timeouts to be longer. I wanted to be able to, you know, have a queue that covers, let's say, half an hour, but ban somebody for 6 hours or a day or something like that. I mean, the problem is I check this every time, right? So this is why I was happy this was fast. Even if it just comes back with, no, this IP ID set doesn't exist, right? Because basically to do... I'm thinking right now, because I can on the fly create a sorted list, sorted by date and time, trim the list to a maximum length, right? And then, but that's a relatively expensive operation. And if I'm trimming one item off it, and somebody just adds a lot of items, and each time I'm trimming one item off and then adding one item, trimming, I don't want to have an expensive operation for that, right? That's why for the base case, which is this, I wanted it a simple area where I'm adding and removing items. And I might even make this a proper circular index with a tail and with a pointer on it that just goes along it. And I'm not actually shifting anything or popping or pushing or anything like that, right? Ciao, guys. And now I'm thinking back to actually creating a data structure for that, because both of these are indexed or would benefit from being indexed by IP ID, right? And now I simplified this to just to be the DT value, right? So if I create the simple index where the index itself is an IP ID combo, but I also want to access it by those. And I'll basically want a linear list, a linear array, so we want to have a check if it exists. We want to have two. In the Q case, we do need the DT. We don't actually need these, only for the access, right? And we want to be able to get latest off, right? And we can, if we have an indexed version, we can always ensure there's only one ever in there. So I think it makes now sense to do that, right? So instead of a simple index, we'll call it the IP ID index. It, right? And I guess we capitalize it to imply it's a class. And the index, do we want the index to be 2 levels? Or do we want to just make a string out of them 2 values? I guess they're always going to be a string anyways. The annoying thing is, what I don't like is that these strings can be relatively long, and I'm storing all this data twice now, which limits how many I'd rather use that storage space for making the queue twice as long, right? Which now brings me back to, do I want to create an IP ID index, especially if it's shared? So then the problem is, yeah, because I'm just saying, okay, then the IP and IDs are converted to numbers, relatively small numbers. The problem is then we need to refresh them from time to time and all this stuff. I think for now, let's create a simple version, right? So we have this.items and this.index, right? And then we'll just say add, right? And then it's just index or key val, right? Or we'll just say set. So this dot so if this dot index key, we'll just say this index key will reference the items. All right, so we want an add internally, right? And in the case of an add, we'll do this items dot push val, right? And the index to this item is the key. Except if I just have the item, like if I want to say the first item, I don't have access to the key value. The index points us to the item, and the item only contains the value. The problem is the reverse. To go from, hey, what is the key of the last item? We couldn't access that because we don't have a reverse, right? Unless the item's array just points at the index. Does that make sense? No, because we still need both. My brain. Because we need to do the reverse as well, right? So our items need to contain both the key and the value. So we just need to do this eval, right? And then this dot index key equals this dot items dot length -1, right? That's our add. So if it's not in the index, if not in index, this dot add key val, right? Else this dot update key val. So update only really affects so this, and then this dot items idx 1 equals val, right? Update without any checks. This is set. And any kind of push pop on the items we need to actually handle, right? So exists key return undefined, right? That's our exist. Now what we're not dealing with is the whole point of this system is that we have a push pop, right? So this is really an indexed queue, really, right? So we need a push, a pop. Sorry, we need a push and a shift, right? Shift is our removal from the front. Yeah. So our push is really an add. So that's really a push. Right. Do we care about removing a specific item? Probably, but I'm actually not doing that here. But we should have that. So we should have a p.remove, and that's just key, right? So in that case, we'll do this. Then we'll just remove is actually tricky because we need to resort the whole thing if we want to maintain order, which means we have to update the indexes. So that's actually kind of nasty. Is there an easy way of dealing with that? I mean, if order doesn't matter, we can just move the last item into the location, but in this case, order does matter specifically. That's kind of why we're doing this. All right. Normally, I would use the array function in JavaScript to just, splice the item out. And I probably still do that, but we have to update the whole frickin' index. So we're gonna have to loop through them anyways. So all the items between index and the end need to be reorganized, right? So for so len equals this dot items dot length. IDX is this. For let I equals IDX, I smaller than len, I plus plus. We want to say this dot items I equals this dot items I plus 1, and this is minus 1. Right? And then this dot index so const key equals one sec. Items I plus 1 is the item that gets moved into I. So all the items after IDX. So if IDX is like the item before the last one, the last item gets moved into that, right? So key is that. So then key index equals I minus, it becomes I, when it previously was I plus 1, right? Because what's in the index is this, right? Items becomes that. And then at the very end, set items dot length minus. And the original index key is just gonna get deleted. So delete IDX. No. Key. Can do that down here. Right. We'll just remove by key. Okay. There's no guards on these right now. And then the final one is our shift. Shift. It just pops the first item off. So index would be 0. Oh, but all... Yikes. All the... Yeah, we have to do the same operation as this for shift. So we'll just say this dot remove this dot items 0, 0. Right? And do we want to make these key value pairs in items or an array of key and val? Yeah, this is fine. So that's shift. We have exist. We have set, which is either a push or an update. Then we have update, we have push. Exist is probably the most primitive. And then shift can go right after here. Actually, this goes above remove and shift. So update says this. If index is undefined, update should become a push. If IDX... Is this circular? No. If IDX equals undefined, return this dot push val. Right. If IDX is undefined, return, because it doesn't exist, right? If this.items.length equals 0, return. We can only shift if we have more than one item. Set. If we don't have it in the index, if not this dot exists. This dot push, else if this exists. Yeah, I think we're going to do it the other way around. We update, otherwise we push. Update, if it is undefined, we push. Okay. If push we don't care. All right. And then we'll just do a couple of things like p dot length. This dot length equals 0. We can just do this, right? Push this dot length plus plus. Items dot push. Remove. Shift does a remove. Doesn't update or push. Push doesn't increment. Let's put the higher level functions down here. That's all that happens in this case, right? Yeah. We're only updating the value. Okay, I think this is complete. So, now we gotta update this to use the indices, and I'm kind of questioning if I should maintain this code or just like create a second copy. I think I'm just gonna scrap this. This is just overly complicated for now and just doesn't make sense. So we have max queue length. Yeah, let's just do this for now. So we now want the guards and the queue to be both index queues. So then we can have a maximum length on the guards. And we might as well, probably will implement the max length inside the index queue values, right? So queue equals new max queue. Right? And then we'll do the same thing for guards. Right. And then we don't need a guard count. And then a lot of this stuff will disappear. So instead of doing all of this, we're going to change it all. I'm over-engineering this, aren't I? Okay. So, right now, let's just say, boom, add it to the queue. Actually, let's start from the top. Right. So, if we're in the guards, and right now our key is these two put together, right? So let key equals, let's just do something like this, or function create or make key IP ID return IP plus simple type symbol plus ID. I'm wondering if I can just join them without adding additional characters to waste more memory, or if there's a problem with weird weird things in the counter IDs. Since neither of these can contain spaces, I think we can do this. So we just do this, make key IP ID. Let's go back down to a very small number, right? Like if I just output the keys now, simple index, of course, it is now indexed Q. Index Q. Guard count not defined. Yeah, guard count shouldn't be a thing. So we'll do that. All right. So these are our IDs now. And that's why these strings can be fairly long. We'll see how big they get for 1,000 or whatever, right? So, step 1. We assume it's not in the guard. Well, we'll just go straight to the queue, right? So, we'll just say at the end queue.push key dt. Boom, right? I'll just do that, right? And then here at the end we can just say console.log queue way and guards. And I don't know how they will output here. Okay, fair enough. So we'll have a bunch of items in here, and we have an index. And the items are the strings pointing to these, right? These we can potentially optimize, right? Because these strings are repeated a million times. And we'll probably... it's almost like we need to create some sort of garbage collected thing. We'll see. All right. Because the problem is we need to know when a particular ID or something is no longer used. So our index doesn't grow too large, right? All right. So we know this data goes into the queue. So now, before it gets into the queue, we need to check if it's in the guards. We know it's not in the guards because there's nothing in the guards. So we now want to check first. We want to do this now, but now we have an index system, right? So, and now it makes sense for the queue to only contain each pair once, which it already did implicitly, but now we know it's forced to be that way, right? So if queue exists key console.log exists key, right? And no exists here. I'll do this. So these are all unique entries. Okay, so we can get rid of that and make the number a little larger and see if we get any hits in the first 1,000. All right, we get 1 hit. So we have our first hit, which is this situation, in which case we want to check the timeout, right? So console.log key dt, and q dot get key. I think I haven't done a get function. It's just a minor omission here. So we have a set and we'll have a get. Get if not exists, return undefined. Else return, we just want the value, right? So this dot index key, this dot items index key 1, because that is key and value. Okay, so that's the previous time from the get. So we'll just do function check timeout quickly. Do we... Let's just do it manually quickly. So that's our value. We know it exists, right? So we do dt minus. We can just do this, right? Discard timeout this dt. Right. Does that work? Is guard timeout true? Okay, now I actually want to output these two. And the subtraction of these two. DT is larger because it's more recent, because we are going forward in time. So it's 164 seconds between these two. So we have a timeout that's true. So if we have a timeout that's true, in this case, we want to remove the guard. Wait, no. But we're not checking on guards. We're checking on this. So here we should never get to a timeout. No, wait. No. It still could be a timeout. In fact, that's why we're checking this. So if it's a timeout in this case, we in this case, if we have a timeout, we're just going down here and pushing it into the queue. Now we could remove it, but that's actually more expensive. We could update it, but then it's in the wrong place. So we're just going to leave it in there and let it consume an additional spot, because the timeout should be relatively large, larger than the queue. So this shouldn't be a real problem. Okay, so that's our situation here. If we have a guard timeout, we'll just break out of here. Now there's no breaking out of here now, so it's actually the reverse. So if not is timeout, right? Now in this case, we'll have to create a card. Is guard timeout is true. Oh yeah. New guard. All right. Now, the timeout is very short. So if this timeout was 10 seconds, but we're multiplying it by 60, so it'll be 10 minutes. We got a new guard in this case. Great. So, when we have a new guard, is not guard timeout. We create a new guard and we return true. So here, return true. Right? And then we'll say guards dot push key dt. Boom. New guard. Bada bing, bada boom. Right. Now here, if guards exist, and this becomes an else if guards exist, else if queues exist, and then eventually that. Queue exists. Now we have a new case. Guard exists. All right. New guard. We don't hit a guard exists case in this sample. Let's get more samples. All right. New guard, new guard, new guard. Queue exists, guard exists. Okay. So we have our first guard exists. Now, if the guard exists, we'll check the same thing. Do we have a timeout, right? So if guard exists, we'll do it is guard timeout. Except now we'll do it from the guards. And it is not a timeout. Let's look at the raw data like we did before, but now from the guards. So it's 4 milliseconds. 138, 134. Okay, so it's not a guard timeout. If it's not a guard timeout. So same thing as we have in the queue basically. If not is guard timeout. So if it's not a guard timeout, we update it. So this becomes update guard. So guards.set key dt. And then return true. Boom. Is guard timeout false? Update guard. And then in that case, we should get blocked here, right? Blocked. Boom. Just so we see the blocks. Boom. Blocked. 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 All right. So these get all blocked. And yeah, I was just thinking like I should set up a test harness where we're filtering the logs through it. And then afterwards we get the clean logs as if what the logs would have looked like if the system was already in place. And then we should analyze, and then have an algorithm that analyzes that and says, hey, okay, how many, you know, but I think that's kind of, you know, a bit of a waste of time, I suppose. All right, so we dealt with, we have this case where we're returning true. This is basically that. Now, if it's not a timeout, if it's not our timeout, sorry, if it is a timeout, then we'll remove the guard and then it gets added to the queue. All right, so guards.remove key. Now this is the kind of expensive operation because it's an out of order removal and we'll have to basically resort everything else. And we hope that doesn't happen very often. Remove guard. So remove guard shouldn't happen very often. Now queue exists and not having a new guard means it is timing out. Huh. All right. This is, I think, the most frequent log item, right? So if we crank up this number now to 50,000 samples, we get a lot of new guards, yada, yada, yada. Now, at the bottom here, we should be able to say queue.length. Right? We have a length property, if I recall. Yeah. And guards.length. Right. Now, since we're pushing, are we? Update guard, create guard, guards.push. Since we're pushing, the most recent ones should be at the end of the list, which means if we implement a max length mechanic, this should get handled for us, right? All right, let's get rid of this. Boom, boom. So block count 48. We have 49,952 in the queue. Right. So let's implement the max length. Right. This dot max length equals defined. Max length. Right. Now setting is a push. There is no other way of adding items in right now. There's no adding to the front or adding in the middle. Right. We can remove though. So we only care about push basically. So if this dot length is greater than max length. Now the problem is we're re-indexing the whole array in this case. Can I just use a sparse array? So what if instead of, in the case of shift, what if we don't re-index things? So our index numbers get larger over time, right? But we know we only got 40,000 or whatever, and we can always do a re-index from time to time, right? Because the shift would happen every time we're adding an item at the end, we're removing an item to the front, and if then all the indexes change, we're gonna have to reorganize everything, right? So okay, so instead of using the index number, can we do a direct reference? Do we ever care about the index number? No. Right. So when we're doing a push, what if we literally just put the item here, a reference to the item? So if we do this, right? Right. Now, this stays the same. Update, push, or we're updating the items directly. No. So, update. Items IDX. So no. So we want to do item is that if item equals undefined, return this dot push, else item 1 equals val. Right? And then here we can just do that. We don't even need to, we have a reference to already. Right. Now, the problematic part becomes the remove, right? So push is this dot items dot length -1. The item we've just added. Or we can just do this, right? We can say let item equals boom. Items push. Items this. All right. Now, this is basically the tricky part, is when we're doing a remove. Except now we want to reorganize how we do the remove. And is the remove used anywhere else besides the shift? No. So for now, let's just do this. Right? And the shift isn't currently being used yet. So far everything should work the same. Guards.remove. So we do have a remove here. Okay. We can literally just delete it out of the array. We don't care what the indexes of the array are. Right. So when we're doing a remove, we're just gonna leave a gap in the array for now. The problem is, if I delete an array out of the middle, okay, JavaScript sparse array. What is the memory requirement for an array, for a sparse array? Holes and empty slots where elements are missing have not been explicitly assigned a value. And every index from 0 up to sparse arrays can have gaps in the indices. Non-contiguous elements are not necessarily stored at very consecutive position. Because now I'm thinking the length property of a sparse array reflects the highest index plus 1, even if there's empty slots before that index. So we could, by making the max length slightly larger, we could tolerate removals from the middle, because eventually those holes would just get pushed off the end anyways. So a remove doesn't actually reduce the size, but once we exceed the max size, we're pushing out front. So is that a big problem? Explicit removals shouldn't happen too frequently. I think that's okay. Because a removal implies a timeout. I'm just thinking right now, if I leave the removed items in and they eventually take up a lot of the space of the guards, would inactive guards like that push out active high priority guards, you know, that are currently being spammed? Or is it worth doing the expense of re-indexing at the point of removal here? Because we could do a couple of other things as well. We could say, okay, every 100 removals, do we re-index, right? So instead of keeping it to a fixed length, let's say 1,000 items, so every time we add one item, remove one item, we could have 2 lengths, right? We could say, okay, we let it grow to 2,000, then we shrink it to 1,000. Let it grow to 2,000, you know, and obviously this would be more likely from 10,000 to 11,000, right? So it only shrinks every 1,000 items. And that's kind of where we have our performance savings, really. All right, let's think about what a wholly removal will look like, right? So instead of doing all of this, we basically say, we'll say, okay, so we say item equals this dot index key, idx equals this dot items index of item, right? And then we'll do delete this dot items idx, and then delete this dot index key, basically. So if I do this, it should run, but our queue length will still grow. And now if we're implementing the max length, and we'll set them to some arbitrary value for now. So we'll say 2,000. And we'll do this. Like let's do something like this. Right? Yeah, so we have max length and max growth. Max grow size. Let's call these size because they're just one item. Size, max grow size, plus max size, right? Max size, max size, max grow size, right? So this applies to push. So if this dot length is greater than this dot max grow size, console dot log size exceeded this dot length, and I'm mixing size and length, which I don't like. So max length, max grow length. Right, and we'll put the other one in here as well, max length and max grow length. And then we'll reduce the sample count, because if it's around 2000, let's say we want to go to 2510, so we don't get hit with 1,000,000 messages, right? So we're exceeding the size. So then we basically want to re-index. Now the question is, what's faster? Building brand new index items or shuffling them about and not allocating additional memory? Because basically what I'm thinking is, let's say once we reach 2,500 items, we want to loop through items 500 to 2,500 and put them into indexes 0 through 2,000, right? Or the other way around, right? So we want to go for I equals, so let I equals 0, I smaller than, and let's do these 3 values because we want to have all of these accessible here. Right? So if length is greater than that, smaller than max grow length, no, max length, I plus plus. And let's make these just 20 and 25 for now. And then just make this 26 or 27. Size exceeded, there we go. So if we do this, we should get that. For each size exceeded, we should get 0 through 19, right? And we want to add the difference. So const delta. No, we want the delta is this is when we're triggering it, but we only care about these, right? So delta is max length minus max length. Right. So the delta should now be 7. So that means I plus 7. That's the value we want to put in the new slot. So 0 will get the value 7, and 29 will get the value of 26. Because the current size is 27, which is this item, and that'll go into the last spot. And the 7th item goes into the 0th spot. And now we'll have 0 through 19, which will now represent 7 to 26. And we'll have cut off the first 0 through 6 items. So the first 7 items will be removed. And our length will now be 20. Yes. Right. And to do that, both... I'm just thinking, no, the index needs to be completely wiped. Because the index... no. We basically need to remove the first 7 items from the index, right? So first, we'll go from 0 to delta. So, those are the items we need to remove from the index. Just completely remove them. 0, 1, 2, 3, 4, 5, 6. Okay, so this dot index 0. That's our key, and we're just going to delete these. Right. So this dot index object dot keys dot length index dot length. Right? And if we do this before and after, what does that look like? Index dot length 1 1 2 2. Oh no, there's gotta be only when we're doing this. Not every time we're executing push. Right? So index.length goes from 26 to 20, right? And we'll do the same thing for items. Now, object.key on items, I don't think works the same way. So we'll just do this instead. So that currently will stay the same. 2026, right. And then here, we need to move the item, assuming the index is already clean. So then we'll say this dot items I becomes this dot items I plus delta. Right. And this dot items. Okay, so let's do this. Const item equals this equals item, and this dot index item key. Ah, no, the index doesn't change at all, does it? Because the index is based on the keys, doesn't care about indexes, and is direct references. Okay, so actually, that's really all we need to do. We don't need to touch the index for this, which is nice. And then at the end of that, we'll do this dot items dot length equals max length. And then this dot length equals this dot items dot length. Right. So afterwards, we'll get there. We don't need to do this. These should be relatively quickly. And now let's also output the first item of each of these. So items 0, 0, and items delta. Delta. Just to verify these have been moved. Like if I do this, move the delta here. So 2020 delta 0, item 0 is this, and item 6 is this, and now item 0 should be this. Okay. And now the question is the index still coherent? So index, and the item we're going to look at is this. So that's the key. And that's what we'll do for the index, right? And we'll also do something like items index this, right? We don't need all these. This is everywhere. Okay. Index that. And index delta. And it does make sense for items. We don't care about the delta items at the end. We just care about the zeros. All right, so index at the start, item is 0 is this, index index of the 0th item. No, I'm an idiot. This is still 0. This has got to be 0. 0. 0. And this is at the end, right? So this is corresponding to this, and this is corresponding to this. And now at the end, index 0 is this. No, not delta. God damn it. What am I looking at here? Items 0, item 0. Yeah, that's what we want to look. We want to compare to this row. So before index and then afterwards, item 0 is this, and index because it doesn't change. Okay, so the index will automatically be correct for this. And this isn't too expensive. We don't move anything in the index, and we move, well, we move all the items, to be fair. But we're not doing this super often. Okay. So, if I now sanitize our logging here, let's check. Is everything updated after this? I think so. So now this size exceeded happens once, and if we keep going, it'll happen every 5 items. Size exceeded 26, 20, 25. Every 5 items over 500. Right. So now if we make these larger, it'll happen every 500 items. So if we go to 5,000, it'll happen also 5 times. Okay. That's not too bad, right? Every 500 items, whatever. And we can make this bigger. And this, okay, so now this is on push. On remove, we currently leave it sparse. That's fine. We'll make it big enough that that's fine. I think so. Like, we don't necessarily want to do this. We could filter these out in this process, but it probably, by skipping past them or whatever. But this is a fairly efficient algorithm, so maybe that's not worth doing. Okay. So now, if I don't output this, our queue doesn't grow too big, and we can run this for a longer set of samples. So here we have 5 blocks. Now, I should have recorded it against the previous system, how many blocks we had for, certain numbers. it would have made it easier to say, okay, it performs the same, but we don't necessarily need it to perform the same. It's going to be an imperfect system. It needs to be good enough, right? So where are we at the end here? We have a queue length of 2,357, so the queue length will stay between these two numbers. It'll grow to this, and then it'll get shrunk, and so on and so forth. Our guards are relatively small, so that grows much more slowly. So what we'll probably want to do is a relatively small guard size and a relatively large queue size. All right, let's go farther. Let's also not necessarily output this each time. We'll just count the total blocks, right? And then here we have how many times a guard got updated. Guard exists is timeout we don't really need. Here we go. We can shrink our logging a little bit. So we have guard exists, we've got an update guard, and we've got a remove guard. So every guard exists. Okay, so if I put this here and here, you know, because we'll have one of those two for guard exists, so need that. Update guard, remove guard, update guard, remove guard. So over 100,000, we only have this many events over here. And the whole thing should be fairly efficient now, at least from the part that's, you know, dealing with these indices. Okay, now this is where we're hitting our case of 40,000. You know, the thing we're trying to avoid. All right, so this is where we're getting up to 370 milliseconds. Now before, I think we had about 4 seconds for the whole thing. So this might be faster now for 900,000 rows or whatever. Because of the indexing, right? Yeah, and in fact, it's 600 milliseconds, right? What we could also now look at is what is the total size. It's a little tricky to think about because... Yeah, so I'm thinking, okay, so the item is stored once. So we have the index and the value, the key and the value stored as an array. The thing is, the keys are also stored as the strings in the index. Now, can we store? Like, I'm trying to think if there's a way of storing the keys once, but I don't really think so, because if I want to, if I want it, instead of storing the key also in this array, we couldn't do any of these things, right? Now, if I wanted to store a number instead of the key, we would have to have the key itself be an indexed list. Otherwise, we'd have to do index off every time. What was that noise? It sounded like a loud squeak. Okay, I don't know where that came from. So I'm trying to think if we... Basically, I'm saying, okay, those 2,500 strings, can we turn these into integers and then index the index by those integers and store those strings only once, right? The thing is, any reference for a key would have to go into an object with a key value pair to turn it into that number. The problem is also then, if we want to remove a key from that list, we need to have a reverse index, and then we're back to storing it twice. All right, I think that's a premature optimization. I think right now we can, you know, I can just say, okay, how big is this, right? So we can just calculate the size. And I think as a rough estimate of the size, we can just turn it to JSON. So for example, guards size could be JSON.stringify guards the length. Now, what I don't know is how big this will actually be. I mean, how comprehensive this JSON object is going to be. I think it has everything. It'll have everything in there, even though I don't have a to JSON handler here. Max scroll length, length, items. In fact, this is bigger. And here we have the holes that shouldn't be too frequent. Okay, so if I do this, this will be larger, which is fine. As long as that's okay, whatever length this is, then it being small is not going to be a problem. So our guard size is 150k, and our queue size is 387k. So that's perfectly fine. And the guard size here doesn't reach the full size, right? So around a half a megabyte for a queue of 2000 to 2500. The larger that range is, the less CPU. The smaller the range is, the less wasted queue size sort of thing. So there are all trade-offs, right? That's how it is. The code here gets much simpler. And here, for example, we'll have 40,000 blocks. Yeah, so that includes those 40,000 bad rows, which we want to block, plus around 952 other things we want to block, right? What we don't do right now here is cooldowns, but once we have a max bounds on the size of these, we don't actually need to actively cool them down, because they'll just get removed eventually, right? And we do check our timeouts here. So I think we can actually simplify this now. Remove all the logging. We don't really need any of that anymore. We want to return false at the end of this. Queue push is all we need to do. We don't need any of this. We don't need to take care of the max queue length here. Right? So if we have a guard timeout, we return true, which means, hey, it's a block. We don't have a timeout, and we have a guard. If we're adding the guard, we don't care about that it is also in the queue. We don't remove it or anything like that. Is guard timeout queue.get key dt. If it's not a timeout here. All right. Now, the code here is identical, and that's why earlier I was wondering, if guard exists. Yeah, we're not pushing here. Yeah, it's so similar. That's why I keep wondering if I can turn them into one thing. The problem is when we're updating the queue, we'd have to move the item to the end so it doesn't get pushed off the front. Hey, Mark. Texel. From Texel. Is that a place? I assume that's a place. Oh, okay, it's an island. Ah, that's where you're holidaying. Well, I hope you have a great time there. The photos you sent looked lovely. All right, we're 4 times faster now as well. Memory is really not a big deal. Let's see if we make it much bigger, if this is gonna be a larger issue. So what if we do something like this? So if we have 1,000 item play and we have 40,000 hits per day, and 40,000 is not the number of counter increments, it's the number of visitors I have to the site. So the number of counter increments should be less than that. Except obviously somebody hitting it with a spammy thing doesn't actually go through my analytics. So, but at most that should be 40 trims, right? And I'm wondering if the trim should actually be a separate function call. I think we'll just do a trim here, right? So we can just do this. Right? And then at the end, we'll just reset the length to items.length. Length is always going to be items.length, so this should really be a setter-getter. MDN properties define. So we kind of want to do this. Boom, define property. This length value doesn't have a value. We just want to have a get set. Get and set. So get is a function. Return this dot items dot length. Right. And do we need a setter? It's called with one argument, the value being assigned to the property with this set. No, we don't need a setter. Undefined. Actually, we can just do this, right? And then we don't need to update length at all. This dot length. All right, if we run that, is it gonna complain? Ooh, didn't like that. Check failed, index is smaller than size. My god, why is this crashing in these weird ways? How's the audio, by the way? Nobody seems to be engaging with what I'm saying, so I'm wondering if I'm accidentally muted or something. All right, this is not a good sign. That's not a good SI now. If I do a smaller run, it's taking almost a second. Holy moly. Did I do something weird with length here? Or is literally that function call a problem? What if I use items.length internally? Or what if I say items length like we do this, for example. Wow, really? If I get rid of that here, I'm gonna just do this. Items length. Let me just get rid of that. Ah, wait. Here, this should be this dot trim, and then none of that. Right? Is it really that much of a problem? If I don't have this property at all, what happens now? 0.8. 5,500. Why? Oh, is that just the time it takes for the files to be read? Okay, 5,000. Do we not use length here? We're using length. Oh, that's because it's undefined now. 50,000. Okay, so this is the size, the timing it takes just for loading the files, I'm guessing. Yeah, so 100,000, we're still at 0.9 seconds. So if I put the property back in now, so length doesn't return undefined anymore. This is longer. but we have numbers now. If I do 200,000. Okay. So internally, we're not using that getter setter, so it shouldn't be a big deal. Okay. If I go back to a large number here, it should be just 900,000. What's in the file? Oh, 800,000. We're now at 2 seconds. That seems slower. Why is it suddenly 2 seconds? What did I do that made it slower? Is that actually faster? But this shouldn't really have a big effect because this shouldn't happen very often. Items, not length. That's weird. Why is this suddenly slower? We're executing this function here every time? Items index. I mean, it's one extra function call. And push gets called, I don't know, 800,000 times. It shouldn't be an extra second of time. What if I just move that here and get rid of the function call? Is that really gonna save us a second? No, I don't think so. Yeah, exactly. That's what I thought. Huh. Don't know what I did wrong here, or what I mean, the time is still fine. I'm just kind of curious what I'm doing differently here. I mean, check rows is only 787, so the rest of the times, maybe it's just the JSON stringify, and I forgot that I've added that and hadn't looked at the time since then. No. Check rows. That's where we do all the check hit stuff. So where does the rest of the time happen? So we don't do much else. I mean, it's the file reading, I suppose. Maybe I'm confused. Maybe earlier I was looking at the checks row timing, and I wasn't looking at the process timing. So maybe I wasn't paying attention to this, and I was just looking at that. Because this is over a second even back here, and I'm pretty sure that's before I made these changes. Yeah, in fact, here check rows 1.9. And then I remove the logging. It goes to 371 for 500,000 rows. It's over a second. And then I'll go to the full row size, 678 milliseconds for the checking. Yeah, we're at 1.4 and 1.7. Seems like we're a little bit more now, but it's JavaScript, so you can't... It maybe because we increased the size for the indexes over here. All right, since a lot of this stuff is now in this here, I think we can get rid of all of these. Like, none of these are happening. Except for isGuard timeout. Like these. I think none of these we'll need. Right? Guard size now 800,000. Queue length, block counts 40,000. Okay. We have make key, isGuard timeout, and check hit. All right. We don't need that. Don't need that. We have a couple of constants. Max queue length isn't really a thing. Let's just do that. To be fair, these numbers should be... So max queue length equals 4,000. Queue buffer. Queue growth. All right. That. Timeout is now 10 minutes at the moment. So we probably want to make that timeout a bit larger. So maybe 30 minutes. Boom, like that. And that'll give us a larger block guard size, ultimately. And slightly more blocks. Okay, that's fine. And now the algorithm is quite compact. I don't think I actually need to reduce that much. We can basically wrap this up. Discard timeout is used twice. That's fine. So we just need a little bit of configuration to pass in and the test data. This gets all its DTs passed in. So this is all of it, really. This is what I want to put into an object now. So I should run it on more test data. I should run it on... where's the config happening? Config... config. Oh, I just looked at it and then I moved. Oh, wait. Ah, here we go. Here we're initializing the config. So this stuff we don't care about anymore. I think that's fair. And we are running init and then start2. Does start2 change? No, that's just taking load test data config. Load test data does that. Oh, okay, that's where we're actually filtering the file names. So if I want to run this on another date, let me just go into the backups place. And this is backup dir is here. And then we're just looking at these. So if we want to use something, I think where we have a larger... So this one is this folder, right? And we're looking at the PM out. API out. Okay, so we were looking at something like this instead. API out. So if we're looking at this one instead. So let's try this one. Instead of this one. Instead of this one, we'll try... well, basically any of this, right? We don't actually care. Like all of them. 07 to 08. That's how many days? Should be around 30 days, right? Yeah, okay. So we don't actually care about these. We'll just wildcard them. And now if we run it, we'll get more than... or maybe not. Roughly the same number of rows. Was this already 30 days? No, it was also 30 days. So, okay. So that seems to be just roughly what we can expect, I suppose. If I get a backup from earlier in the year, like this one, for example. Oops. So what if we look at this one? Should also be roughly 30 days of data. Yep, that's from 2024. Hey guys! That's also around 841. That's... Is that weird? No, here are the files. Okay, so that seems to be fairly steady. So a roughly 841 entries for every 30 days. So if we change this to back to this test month, And here we can see, okay, and we can compare, right? We have around 150,000 different IPs. Here we have around 180,000. So the numbers do make sense. Or it's, you know, here slightly. Okay, so here we have more counter IDs, but that, you know, within, this makes sense. This is not somebody spamming 100,000 different strings or something into the API. Hey Keith, it's just the problem is way beyond a simple analytical chemist. Oh, chemistry is way beyond a simple programmer, I tell you that. I fondly remember organic chemistry, but man, it is complicated. It is so complicated. I made my first chemistry molecular model using a ray tracing tool called Polyray back in the 90s, where everybody else was using gummy bears and toothpicks for their models. I 3D rendered it and printed it out. That's how much of a computer nerd I am. All right. So the size is also fairly consistent. So it's just about a megabyte of memory, which is fine. And it doesn't, you know, it can't grow beyond that. What I'm not checking is how big the queue window is getting. So that would be something that might, and I don't know if it's worth checking throughout. I guess I can do this. I can say something like let max queue window equals 0, right? And after every hit, I can just update it, right? So I can say queue dot items 0. That'll be the DT. So it's math dot max, whatever is the current one, or this new one. And the length should be the last item. Dot length minus 1 minus the first item. And these should be the DT values. And that should be our max queue window. And then we can, at the end, we can just output that. And that should be in milliseconds. Math dot round. Let's convert it to minutes. And what would that look like for this particular time period, May and June? Max queue window is 0. This one should be larger. Let's look at these separately. So the last item should be that. And the first item should be, the first item should be that. And the last item should be this. And the difference should be that. Right? Oop. Okay. Why does the math.max? Oh, because I'm assigning it. All right, I'm getting tired. This gotta be near the end of the stream. Near the end of the stream. I wish I still had that image. I probably, it was culled through one of the my moves. So max queue window is 368 minutes. All right, so that means 6 hours. Oh, that's great. Okay, so that means we can detect within 6 hours, and we don't need 6 hours, right? Because our timeout is shorter than that, right? Our timeout is 30 minutes, right? So anything over 30 minutes will be timed out anyways. So we can now tune these and can say, okay, if this is 3000, we don't use up as much memory. I don't think it'll save us any time, actually. It probably doesn't save us any time. It'll be a slightly faster when we're trimming the queue. Yeah, so now this would be 300 minutes, which is 5 hours, which is still huge, right? So we probably don't need a huge queue if we want to have a half-hour window or something. Let's see, 159 minutes, right? So the maximum queue window. Oh, we're actually caring about the minimum, right? Math dot what is it, max integer, max say integer. AI, figure it out for me. Here we go. So if we use this, and we'll go for the minimum queue window size, right? This will always get me the smaller of these two. Yeah, sorry, I don't know why I was looking at the max. The max is nice to know, but it's an ideal case, right? The minimum, it's not on math, it's on number. The minimum is 0. It's because we're doing this when the queue is very small. I guess we want to check if queue. Yeah, okay. If queue.length is greater or equal to that, then we'll do it. Right, so we've got to make sure the queue actually has, you know, 1,000 items in it or something. Okay, so that can give us only 9 minutes. Okay, so that makes more sense now. Because before I was looking at the maximum size. So maximum size is on a quiet day when the queue doesn't move very quickly. So, all right, let's go back to 4,000 items. And the minimum queue size at 4,000 items is 39 minutes. Okay. So we could tune that, but I think if we go below the 30 minutes, occasionally it's not a big deal, as long as we don't go like down below 5 minutes. Because at 30 minutes, somebody can add 48 counts per day. So if they're very patient, they can boost a puzzle by a couple of... over a year, they could still boost pretty significantly. So maybe the timeout should be 60 minutes. And then our queue size might have to be a little larger. So if we go to 5,000, for example, now we have a 50-minute queue window. So I think most of the time we'll probably, because that's the absolute minimum. So this is like the busiest time of the day when a lot of items. And in fact, if it includes the spammy thing, then that'll be interesting. That, yeah, because it won't be in the queue. Because it'll hit the guard and then it'll go in. Okay, so that's why I have 2 separate lists, right? So if somebody starts spamming, they don't flood the queue and remove everybody else from it and push them out. So somebody with 2 IP addresses could otherwise just overload the system, right? All right. Could they I mean, the one thing I haven't considered yet is adding a ban for somebody that's spamming across many, many different puzzle IDs, right? And the other thing I haven't looked too deeply into yet is, I guess I want to do this check after I've validated the counter ID, but I'm not sure if I'm actually validating counter IDs right now. Like, I'm not checking if a puzzle exists for that counter ID, right? So I'll probably, yeah. All right, so I guess the final step now is to wrap this up into its own object. And I think that object would live down here as well. Now, since we're not converting the IP addresses in this case, we probably don't need any of this stuff. In fact, let's move the index queue out of here. Because this is just helper really for this, you know, toolkit. But in reality, we don't actually need that, right? So we have this here. We don't have that there. And then the counter queue is really this. That's an index queue. So now we don't actually need a counter queue. We don't need this. And we'll really just now need to wrap up basically check hit, make key and discard. Like, this is the entire algorithm. And obviously we're not running it through log rows, right? Now what I need to figure out, well, figure out is not really the problem. I need to plug it into here, right? So what do I have access to? So we have set counter value, handle root counter. So this is where we need to do the validation, right? No, not here. This is just reading. That's fine. Increment here. Here's where we do the validation. So basically, this dot set puzzle ID. Option max puzzle size. The config counter exceeds max puzzle size. This puzzle info, counter info puzzle ID. Counter ID. Set puzzle ID. Log object puzzle ID is true. Log request. Counter set counter value. Yeah. So we want to do this here. And as far as I can tell, we're not validating because this thing doesn't have, yeah, this was built before the puzzle database. So as far as it is concerned, it doesn't have the puzzle database, right? All right, guys. That's now the final step, right? So we need to wrap this up. What do I want ultimately? What is the interface? Okay, let's build that object, right, actually. So, what do we call it? Counter protection. Counter protect. Let's call that. Boom. And we'll just have something like this. Counter protect. Counter protect. Boom. Right. Counter protect now has to have a little bit of config. And internally, it basically does this, right? So that goes in here, more or less. Right. These are internal, right? So we'll just have options, and we'll do this dot max queue length equals ops dot max queue length or whatever, default of 100. Queue growth, let's do that, 500, and then guard timeout, let's probably default to like 5 minutes and 60 or 10 minutes, say. And then this dot queue and this dot guard. Right. All right. So that's all of this. Don't need that. And then we'll just replace that with this kind of syntax. Like that. So p dot is blue. This guard timeout becomes that. And p dot check hit equals that. And that's really kind of it. Right? And then instead of doing this, we'll create one of these protect objects. Right? So let protect equals new counter protect, and we'll have a little config object with those couple of properties that we just defined. So we have max queue length, which is 5,000. we'll have queue growth, which will make it 1,000. We'll have guard timeout, which will make 60 by 60 for 60 minutes. Right. And then we'll just do this. And then here we'll gotta do the internal stuff. So that'll be this dot, this dot, this dot. Right. Min queue window rid of. And then we'll do const queue guards equals this. And key can be a const as well. We're not gonna change that. Guard timeout not defined. Oh. Boom. And queue is not defined. Queue. Queue guards equals protect. Let's get them out of there. Min queue window. Don't care right now. Don't need that anymore. Here we go. Takes about a second now. Why is it slower? I mean, not much slower, but did I increase something here? I think, yeah, we made the window larger, right? So we don't need that anymore. Right. And that's basically it. So we just create one of these things. We'll pass in some data, and over time it will do its thing, right? And it's either blocked or it's not blocked. And we might want to, I don't know if we want to do a reset, but since we are going to have real date and time values, because I'm thinking like, if we run test data through it or reset it or whatever, but as long as the date and time is in there and is real date and time, it shouldn't care what's in there. And it should always keep itself within these between 5,000 and 6,000 items in size, right? And it seems to be limiting itself to around max, I'd say around, double that, because that one is roughly almost full. So, 2 to 3 megabytes of memory, which is nothing compared to all the 3 terabytes, I think, 3 gigabytes that I'm currently using for the puzzle database. And this is for a whole month of data. So, well, okay, no. We're passing a month of data through it, but these are self-limiting, right? So they shouldn't have a month's worth of data in it. What I don't right now have is I don't clean the guards out. So over a month of data, they don't actually grow big enough to hit the 5,000 or whatever. So guards could be in there long beyond their own timeout, but that's fine. They just sit in there. They don't do any harm, right? So it looks like the guards won't really need to trim. They need to trim once every 2 months, right? So not a big deal. Okay, I think I'm finally happy with this. I wasn't happy with it before. It was too complicated and it wasn't really doing its job efficiently. And like this, it looks like something I can actually deploy and be fairly certain it'll be functional, it'll be safe, and it won't mess around with the server. And the nice thing about it is all it cares is about the data stream coming in. It doesn't have and its own internal queue of storage. And it should be able to deal with a lot of issues and attack vectors and things like that. And it shouldn't open any new ones. That's the important thing, right? I guess the only thing I can do to prevent it from like memory overruns and stuff is to limit the maximum size of the keys and such. So for example, something as simple as trimming this string. So kind of just saying, hey, we're gonna take the first, maximum max. So yeah, so for example, it might make sense to say You can say max key length. All right, and this, it makes sense to have this as an optional argument. And let's say, I don't know, 200 bytes, right? What we could do here is maximum key size. I'm just thinking, do I want to check how big the keys can get before I limit it? So this dot max key equals 0 equals math dot max. So if I do this and this, right? And then output that at the end. Protect.maxKey is at the end of our playlist. It is. Why is it not looping? It was meant to loop. All right. I'm not gonna start it again. All right. So max key is 215. Okay. So limiting it to 200, for example, is probably enough. Basically, it'll only fail if two people with the same IP hit. No, if a person tries to spam two puzzles that are, or count up two puzzles that only differ in the last that both have really long IDs, which is a possibility. All right. So if I make it 250, we'll be fine. So if we say 250, and I just want to protect it against absolute crazy stuff, right? And then we'll say, is it slice? MDN string slice. Is it slice? Slice. Extracts a section of the string, returns as a new string without modifying the original string. Slice. Split starts with substring. There's an substring. Returns. We're not supposed to use it. Substring. Returns up to. Output Zilla. No index is supplied. So 0 to whatever. All right, so we want to do this dot substring 0. Now, does this create a copy of the string? Because basically what I want to do is, if it's larger than that, yeah, okay, so how about we'll do this? Let key equals this. Boom. If key dot length is greater than this dot max key length, boom. Return key dot substring 0 this dot max key length. Boom. Else return key. And then we don't need that. And it should return roughly the same number of guards and counts and whatnot. So we want to look at these numbers and say, okay, how many blocks? Same number of blocks. Same size, same size. Now, if we make the key really small, just to confirm, it'll mess with it a little bit. It won't break it completely, but it'll get a lot of false positives, right? So we expect more blocks. In fact, we get 1,400 more blocks. So we'll get 1,400 false positives, which is like 25%, which is a lot, right? So there's probably a number, like 200 probably. I wouldn't be surprised if we have a very small number of false positives. Block count 42071, 4207. In fact, we don't have any false positives. So the one long key, trimming it at the end off isn't actually a big deal. But by doing it 250, we should be safe. And now an attacker cannot just run our memory out by faking very long keys and things like that. All right. I think this is where I'm going to call the stream. Thanks so much for hanging out. I absolutely apologize for anybody on Twitch who tried to chat. Nobody seems to have done so because my restream chat wasn't working, and it's still not working. Restream. Oh, wait, no, it seems to work now. I saw a Twitch chat message there at least. Okay, that's something. All right, guys. Well, thank you guys for hanging out, and hopefully I can deploy this next week. I just need to get this in progress code out of my head, and I need to close this thing. My brain is overloaded with things I'm tracking simultaneously. I need to finish things and get them out there and done so I can move on to other things. Appreciate your presence, Keith. And Mark, if you're still around, enjoy your holiday in Texel. Take care, guys.